Question 7.47. You see a pair of shoes tied together by the laces and hanging over a telephone line. You throw a 0.250 kilogram stone at one of the shoes of mass m equals 0.370 kilogram, and it collides elastically with the shoe with a velocity of 2.30 meter per second in the horizontal direction. How far up does the shoe move? So here in this question, you have a pair of shoes with each shoe weighing around 0.370 kilogram. We will call the shoe as object 1, which has mass m1, which is 0.370 kilogram. And initially the shoe is at rest hanging from a telephone line. So initial speed of the shoe is equal to 0. Then you have a stone which has been thrown at the shoe, and we will call the stone as object 2, which has mass m2 equals 0.250 kilogram, and it is moving with an initial velocity of 2.30 meter per second. When the stone hits the shoe elastically, it will fly up, and we need to find how far up will the shoe move. So we need to find its height h from the reference point. Now we can use the law of conservation of energy to find the height h, but in order to do that, we need to first find with what velocity did the shoe start moving from the reference point. So to find that velocity, we will first consider the elastic collision between the stone and the shoe. The shoe is initially at rest, and this is object 1, whereas the stone is moving with a velocity v. So this is special case 2 of elastic collision where one object is at rest and the other object is moving. And we can find the final velocity of object 1 as v final 1 to be equal to 2 times m2 over m1 plus m2 into v initial 2. So let's substitute. Mass of the stone is 0.250. Initial velocity of stone is 2.30 over mass of the shoe is 0.370 plus 0.250. When you solve this, you get the velocity, the final velocity of the shoe with which it will start to move up to be equal to 1.85 meter per second. We need to find how high will it reach before it comes to a stop here. So at the highest point, we have the velocity of shoe to be equal to 0. In order to find this velocity, we are going to use the law of conservation of energy. Let's say we take this point as the reference point as A, and we know at reference point the height h is equal to 0. And let this be point P. At point P, the height is h, but the velocity v is 0. From the law of conservation of energy, total mechanical energy at point A and B must be equal. So we write total mechanical energy E at A to be equal to total mechanical energy E at B. Total mechanical energy is nothing but sum of kinetic plus potential energy. So kinetic energy at A plus potential energy at A equals kinetic energy at B plus potential energy at B. Kinetic energy at A is half mv final 1 squared, which is the velocity with which the shoe started moving. Potential energy, on the other hand, since this is the reference point and the height h is 0, potential energy will be 0 here, equals kinetic energy at this position. At position B will be 0 as the velocity of shoe at this position is 0, but its potential energy will be mgh. So we get half mv final 1 squared to be equal to mgh. Cancel off the m's here. This is mass of the shoe. Then when you rearrange, you get h equals v final 1 squared over 2 times g. We divide by g on both sides. Now substitute. Velocity of shoe is 1.85 squared over 2 times 9.81. And when you solve this, you get the height at which the shoe is raised to as 0.174 meter. So this is how far up the shoe will move when it collides elastically with the stone.